Okay, so I spoke about this last year, but we sampled again, and what I'll say is I knew nothing about Legionella in 2021 when I was first asked the question. In some ways, I feel like I still know nothing about Legionella, and other than I have a ton more questions. So Vanessa DeChambeau was with the ISTC, a microbiologist. Sarah Mandebach's on our team, in the audience. A number of the people helped out with this. Water Quality Investigations is a private consulting firm in Mount Horeb, Wisconsin, which is near Madison. They're biofilm experts. They work with communities, private wells, you name it. But Andrew Jock, who runs that company, is just a wealth of knowledge related to those things. So in addition to, a lot of people have helped us along the way. New York Health Department, New Jersey, some of these folks we met at NEHA conferences. Mara Donahue, I reached out to and cold called because of the work she's done with Legionella. And our own Sally Dolan was involved with this project as well, and Erin Huggett was with us until December when she went to Germany to get a PhD. So a lot of folks have helped with this. We've picked a lot of people's brains. I'm a groundwater hydrologist, not a microbiologist. So I want to mention first off that I talked about this last year at our conference. And for most of the stuff for the 22 through 24 sampling, go there and watch that video. What we left it with then was that we needed to sample again because we have all these new questions every time we sample. So I'm going to go through a little background just because I'm sure some of the folks here haven't heard any of this information before. There are 60 species of Legionella or more. Legionella pneumophila is one species, but it's attributed to over 95% of all the cases. Outbreaks are typically pneumophila, and at the same time, outbreaks are always from public water supplies, nursing homes, hotels, things like that, where a cooling tower or the water's not hot enough. Pneumophila itself has 16 serogroups. The only test that can rapidly test for pneumophila is in a hospital. It's called the rapid test. Is for LP1, one of the 16 serogroups. Everything else takes 7 to 10 days. So there's a lot of other species that also cause Legionella or Pontiac fever. And yeah, I'll get to some of the problems with all that. In some ways, we're only looking for pneumophila, so wouldn't expect to find much else, in my opinion. So as far as the disease that's growing, now there's over 10,000 cases identified a year. It looks like pneumonia. A lot of times it clears up and it's never identified, which is why Johns Hopkins estimate the actual number of cases to be 5 to 7 times as been reported. So, and the other problem with it is it doesn't affect everyone. It's people who are immunocompromised, have lung problems, over 50, and so a lot of people just aren't able to fight it off, if you will. And lastly, it's not a drinking water problem, it's an inhalation problem. And it exists from 68 to 120 degrees is where it grows. So it's your hot water, washing dishes, taking a shower. That's where your risk is, which makes it a totally different animal from what we're used to dealing with. And this all started, and we go into testing. So there's 3 methods that are typically used. qPCR, it's identifying DNA. Doesn't matter if it's live or dead, it's gonna tell you if there's DNA there for any kind of any species Legionella. IDEX, ColAlert, everybody's familiar with that, developed Legionella, which is a liquid culture method. It's supposed to detect just Legionella pneumophila, all 16 serogroups. It doesn't identify which. It's been used for years as the only method to test for buildings and things like that for Legionella, including our IWT program, which I'll talk about in a minute. And then CDC developed this gold standard ISO method. It's a plate culture. It's a specific media that is only supposed to grow Legionella. All those things just aren't true, is the bottom line. It's considered the gold standard, though, and CDC even tests or has a certification program for labs that they can get elite certified to test for Legionella based on their ability to detect it using the CDC method. Last summer, I talked to the CDC lead person on Legionella, and she's like, everybody screamed for a certification. All the labs wanted certification. And so we developed this. She said, this is just a very basic, it means It's really the lowest end of certification you could have. It doesn't mean that they're great, it just means they were able to detect it. So by their own admission, it's, the elite certified doesn't mean a lot. Okay, so we sampled in 22 because a well owner had asked a question on a webinar. So after doing some look at that, and again, that's all really in the talk from last year, I'm just gonna talk about some of the results. So we sampled 57 homes. We used Legionella because our institutional water treatment program, which we've had a state water, we sample state buildings, prisons, everything in Illinois. It really was set up as a scale and corrosion program to keep state buildings from either being having corrosion problems or having scale formation problems in all these big buildings. They started testing, I don't know, 7 or 8 years ago, maybe a little sooner than that, for Legionella, but in 22 they were only using Legionella, which is a liquid culture method for pneumophila. So we found 13 of our 57 homes were positive, 23%, and that's, we knew they were the ones doing the testing. We assumed it was all good. So right after this got done, we found out by just looking in the literature that Legionella has false positive problems with other bacteria. Pseudomonas and a bunch of other bacteria can cause it to look like it's positive, but it's not. So our lab didn't know that, and so the next year, we sampled the same homes, or in the end, it was 42 of them, with this using the CDC method. We went to a commercial lab, and the orange here are the 9 that were Legionella positive in 22, and the yellow are the ones that are positive in 2023. Only 1 of the 3 was positive before, and all the others that supposedly had pneumophila were all negative. So, and the one that was positive wasn't Legionella pneumophila serogroup 1, it was serogroup 5, which that just, everyone says serogroup 1 is all you're gonna find. We still haven't found 1 home with Legionella serogroup 1. We scratched our heads some more, decided we'd sample, in 24, we sampled 38 homes. We split the samples ourselves, or no, we sent the samples to a commercial lab. They split the samples and did all 3, PCR, Legionella, and the CDC ISO method. We sent all the samples to Phoenix, I think. And so the colors here are what matter. Some of these homes had very high PCR counts, which is just DNA of Legionella. Like the one down near the bottom, the 19 million in the first draw sample, if you can see that, but it was CDC culture method negative, and it was Legionella negative. So we have all these issues. 24 of the homes were positive for PCR. 20 of those 24 were negative using the culture method. So there's DNA there. It's all dead. Doesn't seem likely, right? Everyone I talk to says that's not likely. And of the 16 homes that were Legionella positive, 10 of those 11 were also ISO negative. I mean, yeah. And it was the same home that had Legionella, or that had pneumophila serogroup 5 that was positive the second time. So now what? Really, I mean, you look at the orange in the middle, some of those, we quantified that. There's a lot of supposedly pneumophila because of Legionella that, there's just, it's not showing up in the CDC method. So what we believed after that was basically that private wells don't have disinfection, community water supplies where all these other cases are and all the outbreaks are, it's all disinfected water. So there's gotta be something going on there. We think qPCR, we know, it overestimates risk. It can't really be used as a health determinant because it could all be dead. There might not be any risk to a person, is the way it was explained to me. Legionella can be positive for non-target bacteria, and I think in a home that's not disinfected, we're seeing a lot of that. And then the CDC method, they sent samples out to 20 labs that are elite certified, and when the value was over 10 CFU per milliliter, they were right 85% of the time. When it was less than that, they were wrong 93% of the time. So the CDC culture method isn't sensitive enough to detect low levels of Legionella even when it's alive. So that's what we really, and so putting all that together, I'm an arsenic researcher. If it's over 10, it's a risk. If it's under 10, it's okay, right? MCL. This is very different. All this is. And so trying to wrap my brain around this, every time we sample, what we don't know seems to get larger than what we do know. And so, is it possible that non-target bacteria cause 64% of the Legionella positives to be, Anyway, so they were all, 64% of the positive were PCR negative, meaning there's no DNA, but Legionella says that there's pneumophila there, right? Can't happen. And so there's just so much we didn't know, so we decided we'd step back and we picked the 4 homes that were positive for Legionella, or with the CDC culture method, and then we picked 2 other homes. We ended up sampling 6, and we decided to send samples to different labs. And so we had 3 labs. One of them didn't do PCR, and so we took was it 3.5 liters, I think? 3.5 liter bottles, first draw and hot water, both from the hot water tap. And in one big bottle, we mixed it, and then we put it in 7 different bottles and sent it to 7 different labs in the end. Three were owned, three samples went to a national lab. They just had 3 different labs that did the analysis in the same way for the other one. So we wanted to see if there was any difference in what they found. One of the questions I had is if everyone's told me that I've even been told if you send them to different labs, you're going to get different results. So that's hard to get your brain wrapped around if a lab can't repeat what's going on, and it's supposedly a standard method, right? We also wanted to look at Legionella, and we couldn't find anyone until 25 who would it's a liquid culture method, so you've got this liquid that turns a color because it's positive. Why can't we put that in a culture plate? And so none of the national labs would do that because there's no SOP for it. But Water Quality Investigations was willing to do that for us. And so we had them do that as well, so we could determine if the Legionella positive was really Legionella or if it was something else. And then Vanessa had worked at our vet med on campus, and they have a MALDI, TOF, which it's a mass spec that the veterinary school uses to determine specific species of bacteria for animals. And it's a really cool tool. Anyway, so we did those 6 homes. We sampled in the fall last year. And, I did that myself. I'm pointing down here instead of up there. You can, yeah. So anyway, those are the homes we picked based on the data from 24. The 4 that are yellow were sites A through D. Site E is the one that's, I think that's green. Is it brown? I'm colorblind, so it's brown. Okay. And then the blue one on the bottom had a high PCR value. And we didn't do the highest one because those folks didn't want to do it. But 10 million genomic units per liter is quite a few. So those are the 6 homes we picked. We went out and collected these samples ourselves. This is a little difficult to read, but on the right, or on the left, there's lab 1, lab 2, and lab 3. So the first 8 rows or so are all the samples with either the ISO method, Legionella, or PCR. In the end, what happened is 4 were in agreement, the 3 labs agreed, but 1 lab disagreed with the other 2 for 2 of the 6 samples. So this means if you sent the same sample to 2 different labs, or you use this lab instead of this lab, it might say it's negative when it's really positive, or vice versa. And the same way with the Legionella results, the labs agreed on 4 of the sites, and they disagreed on the other. And as far as the PCR results, they were all low except 1, which was site E. They were all high, showing a lot of DNA, but even except for E. So these were more consistent for these 6 homes than we've seen with all the other sampling we've done, but obviously there's still problems here. And I included in the blue there where we've had hits before, just to show, like site C was positive 2 years in a row and then was negative this time. So, sorry. So water quality investigations, real quick. They were willing to extract from the Legionella kits after they showed they were positive, and then put those on a culture plate. They were also willing to send us isolates, which are individual colonies. I learned all this last year. The individual colonies that grew on these plates, they're supposed to be Legionella specific, but they grow all kinds of things. And even so much so that the standard method includes using acid and heat to remove some of the bacteria off the top so you can get to the stuff that's below on the media. And so they were really helpful. They've seen it all, done all these things. And they also wanted to work with us, so they have a proprietary test for biofilms. They can determine what type of biofilms. That tells you what kind of stuff's going to be growing there, what things are affecting it, if there's going to be microbial-induced corrosion, all those sorts of things. And so we collected an extra sample that wasn't part of this work per se of their cold water tap. And that was also very enlightening. But you can see here that for Site A, all the things that they looked for, and it gave us an idea of where these issues are. But every home has biofilms, which we already knew, right? A home that's not disinfected, there's too many natural bacteria in groundwater. There's going to be biofilms in most pipes in most homes, even after a couple of years. So non-target bacteria, we found 40 different species of bacteria in the water samples. And so one thing that Vanessa did in our lab, or ISTC's lab, is she took the same samples. She took one set of samples for all these, and she used other types of media. She used a chocolate agar and a blood agar, which are commonly used to grow bacteria, with the same water samples. And so we ended up with 40 different types of bacteria that grew. We identified from 177 isolates that we either got from water quality investigations or that she grew. The MALDI was able to identify 116 of those. 6 were the Legionella we knew we should find. All the rest were non-target bacteria, so some of these were in all these wells. So the 61 that couldn't be identified, we sent for sequencing. We tried to regrow them. They'd been in the fridge for 4 months. Only 13 of the 61 would grow. So one of the things I've learned is if we do this again, if we want to identify all the bacteria in an individual well or an individual home, we have to collect every isolate. We only did 177 because they were interesting. There's probably 3 times that many that grew. And so we really don't know how many bacteria, types of bacteria were actually there. And this quickly is just, in this case, the Legionella samples, which on the 3rd and 4th line, this is from Site D, which is the one we knew had pneumophila, serogroup 5. The Legionella was pneumophila. But we also tried this on a bunch of other cultures, and the D3 is the cold water, and we started finding all these other bacteria. Some of them are either a drinking water inhalation risk. And so these Legionella samples and these are cold water samples, but Legionella found bacteria and said it was a Legionella positive, and they turned out all to be other bacteria. So this is just a blood agar plate that Vanessa grew. Those are what those look like. We took those isolates and put them on a MALDI over at VetMed. And those are the 4 things on this particular plate. But there was a lot of these, right? This is just one of, 70 pictures like this. And they all grew stuff. So just some other types of bacteria. This list is super long, so I won't go into it. Just wanted to show that there's like Sphingomonas. I can't even pronounce half of these, honestly. So I need a microbiologist. Vanessa took a different job and left right at the end of this, so otherwise she would have given me a lot more help, I imagine. So what we learned from all this is the labs didn't agree 33% of the time. The 177 isolates we did look at were only the ones that we thought were interesting. There's a lot more. And MALDI uses a database, and there's a commercial one available when you get to buy the unit. It's like a $300,000 or $400,000 piece of equipment, which is the real problem. And so we don't really know how many bacteria or types of bacteria we're going to find, but the one thing 2 of the homes were over by Champaign, Illinois, and the other 4 were all fairly close to each other over by Peoria, Illinois, and definitely the bacteria in each of those places had some differences on what we found. So there's no real, and we don't have enough of a sample set to really identify even any of that yet. And one thing I forgot to mention is we had no funding for any of this except the very first year, and so the water survey basically picked up the costs for all of this, and so it's really limited because we don't have one time or any resources to do any more probably. But PCR, it seems like it's also affected by non-target bacteria. Site D, which is the one that was positive with Legionella pneumophila serogroup 5, that person after 24 put in a UV unit. Here's the one that's going to bug everybody because it really bugged me. So they put in a UV unit because they had Legionella. We came back the next year and sampled, positive for Legionella. I mentioned this to a couple of people. You know why? Because he didn't clean the biofilms out of his lines in his house. So his UV unit's at the beginning, and then all the biofilms are still there, the Legionella's still there. I mean, he was pissed. But it really taught us something that no one had thought of. I sure didn't think about it. And we had to figure out, why is it still positive? That's exactly why. If he isn't, people are gonna have to actually scour their pipes and clean their lines in their house. Most homeowners can't do that, right? We talk about people can't afford to test. So this works me up because I don't even know what to tell a well owner, right? But what we did learn is that, our concerns about the methods are also valid, and I need to deal with that with CDC. I met those 2 folks last year. They're really nice, and I think, we can have a good conversation about this, but it's just the method variability is there. When I was told about the ISO method, in the end, it's the analyst who determines by visual inspection if that little colony is Legionella or not. So look at those 2 pictures. One's on a chocolate auger and one's on a blood auger. And one of those is Legionella pneumophila serogroup 5, or one of them's on a regular plate. One of them is Legionella and one of them isn't. So we're relying on a visual inspection. I've had, New York State told me that if it's a different analyst, they may do the method just a little bit differently. It could affect the results. So the real problem is we need a better detection approach to Legionella. Yeah, and the labs changed. One of them gave us quantifiable numbers in 24, never said a word. They sent the results the next year and they're like, it's positive or negative. I'm like, where's the numbers? Oh, we don't do that anymore. Okay. And again, lab variability, just the way we report things. There's blue-white species. It's like 4 species that fluoresce. One lab gave us blue-white species, and one gave us Anissa, which is the actual species. Just all these things that you don't know if you're not really in the game, and I had to learn all those things. And the labs gave us data in different units. Some of those, yeah, so you have to go back to the labs. And like IDEX, when I started doing this, I talked to them, they're all great. I had a good conversation with the guy until I brought up non-target bacteria affecting Legionella. Ghosted me ever since. So it's a tough problem, and I think they know it. So this is a Legionella kit, if you will. And so our concerns really, it's all over the map with Legionella. I'm not sure when it should be used, but for me, what I've learned, if it's not disinfected water, I don't think I would, it's worthless because it's too many other bacteria can make it go positive. And that's been minimized but it's in the literature if you look. I just don't think, no one's looking at private wells and systems that aren't disinfected. And that's where we have a huge problem because 99% or 99.9% of the private wells are not disinfected. When I talked to a bunch of experts, and I did show this last year, but it's all true, these folks are supposed to be in the top of the Legionella game. They're at NEHA giving talks on Legionella. Don't worry about non-LP results. If it's not pneumophila, don't worry about it. We only found one so far with pneumophila. And stick with one lab. If you send them to different labs, you're gonna get different results. Well, I think that's important. So we sent it to 3 labs because we're gonna publish this and make sure everyone realizes lab matters. We don't know which one's right. They'll all tell you they are. Yeah, and so the acid and heat thing, Water Quality Investigations said that they did their own little study where they used the method and used acid and heat, and when they did that, they lost like 60% of their positives for Legionella. So the method itself might be the reason why it shows up negative, or it may knock it down enough that it's not high enough quantity to actually to show anything. So we still have a whole bunch of questions. I think this is my last slide, Sydney. 5 minutes? Yeah. So what I think, in all honesty, is that Legionella pneumophila is found a way to be more prevalent in chlorinated water systems, and that's why you find it. Can't prove that today, but I'm going to try. And because private wells are not disinfected, they're not the one that you find in natural groundwater. I don't know how else, if anybody's got any ideas, I'm all ears, because it's a really tenable problem that most of the Legionella industry and research and work trying to protect public health is looking at the few outbreaks there are, which, depending on who you talk to, is between 80 and 96% of all the Legionella cases are sporadic or community acquired, not from an outbreak, which is 9,600 out of 10,000 are sporadic individual cases. Where do they come from? So, and I talk about that in the last talk last year too. The non-target bacteria, I don't think it's been studied well enough on any of the methods. Certainly they grow on the plate, as well as with the liquid culture, and what we don't even know what we need to ask. We have a lot of ideas, but again, we need to do a big study with a lot of homes and look at a lot of specific things to figure it out. I don't know where that's going to come from, at least until the next administration gets in there, because the Healthy Homes Initiative was where I was hoping to take this when we started, and then all that went away. So I'm not sure where you're going to get that kind of funding. So the bottom one is really I started this so I could give a well owner an answer to if they need to be concerned about Legionella in their private well home. And now it's like, what do I tell homeowners about all these other bacteria? I might have skipped it, but of those 40, 13 were either drinking water or an inhalation risk based on looking into literature and all the material that's available for those types of bacteria. And that's it. So, what I said was the temperature range that Legionella grows is 68 to 120 degrees. One of the things that people recommend is that you keep your water heater as high as you can. Some states like New Jersey, you can't have your water heater, like a nursing home and stuff, over 120. So that's where I learned about what's it called? What is it? A mixing valve, right, but it's a thermostatic mixing valve. So we just put a water heater in our house. We have ours at 160 and we put in a thermostatic mixing valve. Just did that last year because of all this. But, my wife made us because of all this. But if you only have your water heater at 120, it's not high enough to kill it per se. Supposedly, a higher temperature like 140, it can't survive more than 3 or 4 days, and 160, it's a couple hours. There's also studies out there that show that they took water and heated it to 160 for an hour, or for a few hours, and then they were able to grow Legionella. There's a thing called VBC Legionella, viable but not culturable. It can get in a state where it basically just tries to protect itself and survive, and it has to kind of come out of that in order to grow. It's amazing, all the things that are there. So the temperature range that Legionella survives, I have no idea, but I guess it's probably below freezing to a very high temperature. I don't know that we can do anything about it. We find it in cold water samples where groundwater is at 55 or 60 degrees and never got hotter than that coming through a house. And so, yeah. Okay, sure. Have you considered using, I'm not sure what DD-PCR is, unless that's a triplex PCR sampling. That's another name for it. We haven't tried to use that. So yeah, and Patrick's here. I forgot, have we even talked today? Where are you at? Oh, right next to me. He's with New York Department of Health. Those folks have been a godsend for me because, you know, New York has 1,400 cooling towers just in New York City. So they have quite a Legionella program. And so I picked their brains for years. And yeah. Do you know what percentage of Legionella positive samples also came back positive for Legionella on moldy TOF? We didn't, I don't know for sure. There were more than 6 hits. So we had 2 samples at each home. We probably had 12 or 14 samples total that were CDC or CDC positive. We only sent a few of those over. And so I don't know that difference. I was going to mention, though, that we had 64% of Legionella positives end up being PCR negative. New York takes a sample, a subset of their Legionella positives and puts them on a moldy or the cultures them. And they were like, oh, about 10% end up being false positives. And I was like, oh, okay, 10%, we can deal with that. And then when we did it, it was 64%. Yeah, so I don't know, yeah, what do you do? All right, so yeah, if anybody wants to talk about this, I could talk about it for days because I don't know what to do. So it's a real concern. We're trying to work on it. But again, we don't have funding. We're really busy with other things. We've had some of that stuff sequenced already, the 13 that we had sequenced, and I haven't really even looked at all that data. But we know we got to do something with it. So I'm going to move to my next hat here and talk about here at the end. Thanks for everyone who stayed, by the way. I know flights and all those things happen, so not a big deal if no one could, or the folks that couldn't.